Okay, so we are frozen. I need to unfreeze. So hopefully at least 1 and 2 should have been pretty straightforward, and you were able to get those graphed okay. So take a look at 1 and 2. You have your center for 1 is at 3, -1. The radius is 4. For 2, the center is at 0, -1. The radius is root 10. And for how you graph the root 10, 10 is just above 9, right? And what's the square root of 9? 3. So I went just more than 3. Okay, because if I'm going to hit 4, 4 squared is 16, and it's not even close to being 16. Okay? Do we need to work number 3 out together? Would that be beneficial, do you think? Okay. Because this idea of completing the square is really the center for this entire unit. And if you can understand completing the square, if you can remember the steps for completing the square, this unit should not be too horrible. Okay. So, first thing that we do is we regroup. X is together, Y is together, and I'm going to move that 3 to the other side. Okay? So that means I will have x squared minus 4x, leave a space. Y squared plus 6y, leave a space, equals 3. So far, so good? Remember doing that? Sometimes you just need to see someone to do it for you. Okay. So then I go, all right, let's say square root of this is x. What is half of this? -2. Squared. What is -2 squared? Positive or minus? Positive 4. So I'm going to put a plus 4 here. I'm going to put a plus 4 here. Because what I add to one side of the equation, I have to keep it balanced. So I'm going to add to the other side as well. I'm going to do the same thing with y. Square root half of this squared. Positive or negative? Positive. And if I put it over here, I need to put it over here. And so that means I get 3 plus 4 is 7, plus 9 is 16. And there's my completed equation, which then means that my center is going to be at 2, -3, and my radius will be 4. Is it all coming back to you now? No? Yes? You forgot how awesome I was in the morning? Did have a wee bit of coffee this morning, so I'm a little bit jittery. No? Okay, you guys have personality and then you don't. It's like you're either one extreme or the other. So you're allowed to wake up, it's okay. And then for 4 and 5, 4 should have been pretty simple. Just always remember that when you put your center in, you use the opposite of your points. Now, does everybody understand on number 5 where my 5, -1 came from? What was it that they gave me? Endpoints of diameter. So that means if I were to have a circle, they're giving me points on either side of that circle. And my center is going to be that spot right in the middle. How do I find the middle? Add them up. Divide by 2. So 2 plus 8. 10 over 2. 5. 5 plus -7. -2 divided by 2. And there's my center. Okay? That's all you do for the center. And then to find the radius, I basically just plugged the center. And the point I picked was the 2, 5 point. And I just plugged it in. So I said 5 minus 2 squared plus -1 minus 5 squared. Figured out that number is 45, so that is my radius squared. Do you have to change what? It's okay, you can ask.
Going over it again, you said change the 7 to 5 -.
Yeah, I said change it because I saw this in my notes and I forgot that was me calculating the center, and then I told you, never mind, use what they gave you. And if you changed it, okay. Just know it's not going to be that answer. Right? Yes? Because this is equal to your r squared, and my equation says it's equal to r squared. Okay? Anybody else? Did we have any light bulb moments in the last, I don't know, what is it, 5 minutes? Kind of come back? Yes? No? Well, I hope it did, because today what we're doing is we're moving on, and circles are kind of like, circles are the center. Get it? Get it? Circle, center. Circles kind of tie everything that we're going to be doing for this unit together. This unit is about conic sections, and we're going to slowly move away from the niceness of a circle and see, okay, if I change some things from this equation, what kind of a figure am I going to have? So today we're moving into the wonderful world of ellipses. Okay? Now, ellipse is kind of like a squished circle. And we have a couple of main concepts that you need to understand about an ellipse that are different from when you're talking about a circle. The center is the center is the center. That's not going to change from any of them. And we're always going to have these two axes, where one goes up and down, the other goes left to right. And this is kind of on a diagonal, simply for the fact that an ellipse can technically go any direction that you need it to go. The ones that we're going to be drawing are either going to be oriented this way, so where they're wider than they are tall, or they're going to be oriented this way. Okay? But no matter what, we call the major axis. What's the difference, do you think, between the major and the minor axis? Major is bigger. The major axis is always going to be your bigger one, and the distance from the center to where you would hit, that is your, what we call the vertices. So that's your vertice, whereas when we're going the other direction, the other side, that's your covertice. Now, the way we do an ellipse, like if you ever want to try to draw one of these and you want it perfect, it's kind of like a circle. Remember, for a circle, we put a nail in the middle and we tie a string to a pencil and you swoop it around. Well, now it's like we've taken that middle and we've split it apart. And those two new nails, those are called my foci. Okay, and then we say, I'm going to tie a string to this piece and to this piece, and then I'm going to draw my curve with my pencil lodged into that string wherever it needs to be. Okay? So, by the way, you will not be given this stuff. You have to memorize this. So, groans, sighs, all of those are appropriate. But you do need to memorize this. It's not as terrible as it sounds, though. So just take this all in for a second. Now, what we're looking at here is an ellipse whose center is at the origin. Now, where that comes into play is right here. There's no number next to my x or next to my y. You see what I'm talking about? That's like saying plus 0 and plus 0. Just like in a circle, if I were to make that go away, that would be a circle whose center is at the origin and a radius of 1. Same thing with this one. But what's a little bit different with this guy is we now have numbers underneath, and those numbers are not the same. So if you look at this guy, what variable is he under? That's under the x. Do you understand what I'm talking about? Under the x, so I go out that direction on the x-axis from the center. This is a different letter technically. I mean, A and B are not the same. But look, that is still the distance that I go out on the x-axis. Now, if we look at B, what variable is that under? It's not a trick question. Why? So that is the direction I go along the y-axis. Whatever number is under the y, that's how far out you go along the y-axis. So unlike a circle where we would do radius, 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 we now have two different numbers. One number goes left to right, one number goes up and down. How can you tell which number goes where? It's whatever variable it's under. Now, the difference between your major and your minor axis is just saying which of these two are bigger. That's it. Which of those two are bigger? And what we've got here is I'm telling you A is the bigger one. So if the bigger number is under the x, it's a horizontal major axis. If the bigger number is under the y, means you go further in the y, it's a vertical major axis. And the thing I want you to underline and star and highlight is this guy here. I done messed up the Pythagorean theorem. I really didn't, I just numbered it differently. Okay? Basically what we're looking, if you kind of look into one of these pictures here, what shape is this? A triangle. What kind of a triangle? A right triangle. The only thing is I'm not labeling the hypotenuse as C here. The hypotenuse here is A. So for an ellipse, what you're going to do and how you relate it to the Pythagorean theorem is you say bigger number squared minus smaller number squared equals C squared. And what C is the distance to your foci. And C always goes in the direction of whatever number here is bigger. And I know right now it sounds like I just said a whole lot of nonsense. This is one of those things where it's a lot easier to do than it is to say. So trust me, it's not going to be as bad as you might think. I do say that a lot. I do personally believe it's true. I want to make sure that you guys notice here, what are each of these equal to? 1. The only time that you're not going to have one of our conic sections equal to 1 is a circle. A circle is the only one that you can deal with without it being equal to 1. All right, so let's try some baby problems. All I'm going to do here is I'm going to sketch the graph, label the center, vertices, co-vertices, and foci. So I like to kind of start with center. Where is my center going to be for this? 0, 0. Because there is nothing next to my x. There is nothing next to my y. For A, B, and C, you're going to look at these two numbers and take the square root. What is the square root of 25? What is the square root of 9? How do I find C? 25 minus 9, which gives me 16. And I'm going to take the square root of that and get 4. Everybody okay with what I've done so far? It's just square root, find your third piece, and now we get a draw. So I'm going to put my center nice and easy. Holla if I'm going too fast. Okay? Then I'm going to look at my x. What's the square root under the x? 5. So I'm going to go 5 in the x direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What's the square root of the number under my y? 3. So I'm going to go 1, 2, 3, 1, 2, 3. I'm going to use that to draw my ellipse. Okay, and if we look at that picture, the vertices, the V's, the vertices, those guys are going to be on your major axis. Is the major the longer axis or the shorter axis? It's on the longer axis. So that means that this is a vertex. That is a vertex. What do I call these things then? It's got the word vertex in it. Not small. Co-vertex. So that's the co-vertex. That's a co-vertice. And then we need to think about my foci. Okay? What number do I use to find my foci? 4. You use C. C finds your foci. So A is my vertex. B is my co-vertex. C is your foci. And what direction am I going to go with my foci? Up, down, or left, right? Why is it left, right? Yeah, that's a really good way of thinking about it. If it was up, down, it would be out of my ellipse. Left, right is the further distance, so I go left, right, and there are my foci.
So do you actually have to draw the triangle like that?
No, you do not need to draw the triangle. I mean, you can if you want to, but not necessary. All right, so this is how to do it with a picture, how to do it with just kind of like listing things out, because I'm not always going to ask you to draw the picture. Sometimes the picture just takes longer. So if I want to find the vertices, I'm going to take the A, the bigger number was under what? X or Y? X. So I'm going to add it and subtract it from the X while leaving the Y the same. So add it and subtract it from the X while leaving the Y the same. So for my co-vertices, my B was under which variable? The Y. So I'm going to add it and subtract it from the Y coordinate, leaving the X the same. And then for my foci, I'm going to use this number, and which variable had the bigger guy? X. So I'm going to add and subtract it from the X, leaving the Y the same. And that's it. And then the center was just the center, which was just 0, 0. Okay? Yes? Foci is always on the major axis. Beautiful. Rather than thinking always left, right, always up and down, it's always the bigger one. All right. Now, I don't know about you guys, but I've got a problem with number 2. What's the problem with number 2? It doesn't equal 1 and not in standard form. Guess what? I can kill 2 birds with 1 stone, make that all happen all at once. I want this to be equal to what? 1. What can I do? Divide by 98. So now I have x squared over, what number would be under here? 1. And yes, it's a very good thing to write that there, trust me. And I'm going to have y squared over 49 equals 1. So let's kind of do this all together now. Where is my center going to be? 0, 0, because there's nothing being added to or subtracted from the y's. Boop. Okay? How far am I going to go out left and right in the x direction? 1, because what's the square root of 1? 1. So I'm going to go 1 out in either direction. How far am I going to go out in the y direction? 7. 1, 2, 3, 4, 5, 6, 7, and 7. Okay, these guys are not easy to draw. Boop. Horrible at drawing the skinny ones, but I tried. Okay, so A is which number? 7. And 7 was done to the which variable? Y. B is 1, and it was done to the x. How do I find C? 49 minus 1, which is 48, and I'm going to have to square root that. It's not pretty, but I can pull a perfect square out of that. What perfect square can I pull out of that? Does 4 go into 48? 4 goes into 48 12 times, right? So let's go bigger. Does 16 go into 48? Yeah, this is 16 times 3. So what's the square root of 16? 4. So this is 4 root 3. And when it comes to C, will I be doing it to the x or to the y? To the y. Because C and A get done to the same thing. Biggest direction. So 4 root 3, okay, so that's going to be more than 4. Square root of 3 is just a little over 1. So I'm going to put it right about there. Actually, no, 5 squared is what? 6 squared is 36. 7 squared is 49. So we're actually a lot closer to that 7. We're like really, really close up here. And to find your coordinates for my vertices, I'm going to add and subtract what number? 7 to the x or to the y? To the y. So I'm going to leave the x the same. I'm going to add and subtract 7 to the y. Jenny, if you're having trouble, stand up in the back of the room. Okay. For my co-vertice, I'm going to add and subtract what number? 1 to the x. So add 1 to the x, subtract 1 to the x. And for my foci, what are you going to do? Add and subtract 4 root 3 to the y. And there are all of my pieces. Is that easier to do than it is to explain? A little bit? If you're still confused, please let me know. All we're doing today is this. This is basically it. There's one skill that we haven't talked about, and that's just how we're going to do completing the square with this. But it is like one step added on to what we did before. Okay? All right, here we go. I'm making huge changes here. Whoa! Crazy big changes. What do you think I'm changing? The center. Well, that's it. So where is my center going to be here? 0, 1. So 0, 1. There's my center. Now, how far am I going to go in the x direction? 7. So 7, 7. How far am I going to go in the y direction? So 6 and 6. Not the world's greatest ellipse, but that's okay. So I had my center was 0, 1. What is A? 7, and I'm going to do that to which variable? The x. What is B? And I'm going to do that to what variable? So how am I going to find C? What is 49 minus 36? 13. And that guy doesn't get nicer than the square root of 13. And who am I going to deal with that on? The x. Y'all okay with how I figure out which variables to do what to? Okay, so now let's actually finish this off. Writing coordinates. So my vertices, I'm going to deal with A, and I'm going to add and subtract that to the x. So where are my vertices going to be? 7, 1, and negative 7, 1. You can see the caffeine working. I couldn't draw a 7. Squiggles! You look like you wish you had coffee this morning. Yeah. Okay, now we're going to do the co-vertices, where I'm going to add and subtract 6 from my y. So where is a co-vertice going to be? 0, 7, and 0, negative 5, because we're adding and subtracting it from the y, which we actually have a value in there now. Now, I know you guys are going to love this. For the foci, I'm going to be doing root 13 to which value? Done.
So you done with the graph of the foci?
I hadn't done it yet. I was just like calculating it. Well, done with the foci. That was nitpicky. All right, so square root of 13. Give me a number that's close to that, has a perfect square. 16, and then what's on the other side of that? 9. So we have 16 and 9. So that's 3 and 4. And I think we're probably smack dab in the middle of those two. So I'm going to put it here. So there's my foci. There's my vertices. And there's my co-vertices. Yes, ma'am. Nope. I know. Everybody wants a calculator all the time. It's just a little security blanket. All right, let's see if you guys can knock number 4 out on your own. All right, check your answer. Did you get what I got? No? Yeah? B. Take a look. It's on the board. So questions. I know there's a lot of little points to look at here. So how do we do? Good? I mean, I know you guys were asking whether or not you could have a calculator, and I know that the calculator is really only that square root part, but in all honesty, the math that you're doing here, it's not ugly. It's add and subtract to something. So that'll take us to our general rules. You have this all in front of you, and basically what you're going to do is, again, A is the larger number, so that makes B the smaller. And how do I find C squared? A squared minus B squared. Okay? Now, if you're talking about a horizontal major axis, the A is going to be under which variable? The x. So that means I'm going to take the x coordinate and I'm going to add and subtract A. And I'm going to keep the y coordinate the same. If the larger number is under the y, then I'm going to take the y coordinate and add and subtract that A from it. Those are your vertices. Covertices is your smaller number, and if it's under the y, you add and subtract it to the y. If it's under the x, you add and subtract it to the x. Now, for my horizontal major axis, my foci deals with C. Who am I going to add and subtract C from? From the x. Because the vertices and the foci always get done to the same variable. And that's it. See, if I had led with that, you would have been so confused. So I didn't. I've done that in the past, and it was a big mistake. Let's color code. Come on, Augsburger. Color code. It's more fun that way. I'm just too exhausting for early in the morning, right? Just too much. Poor Brooke. She's like, why did I have to sit this close to that crazy woman? You chose that seat. Okay. Now, for this, we're going the opposite direction. And you really have a choice as to whether you want to graph it or if you just want to work it out mathematically. So if I graph this, I can just plot the points. Negative 6, 0, positive 6, 0. My covertices are at 0, negative 3. Nope, I did them the wrong direction. I know up and down and left to right. Trust me, I do. Sometimes. We'll have 3 and 3. And if you are a visual person, that might really help. And I'm going to do both visual and mathematical at the same time. So, vertices and covertices. Where do I find the center? Exactly in the middle. So, where would my center here be? 0, 0. How do you find the middle of 2 points? Add them and divide by 2. So negative 6 plus 6? 0. Wow. So the center is 0, 0, just in case you didn't get that from the picture. Then I have A, B, and C. Look at your vertices. Which coordinate changes? The x. So that means I'm doing A to the x. And how far do I have to go from 0, 0 to negative 6, 0? I need to go 6 spaces. Co-vertices, what variable changed? The y is what changed. How far do I go from my center to one of my co-vertices? 3. Now technically here we do not need the c because when we're looking at my equations, all that's in here is a squared and b squared. Sometimes they'll give you information that'll give you the c and you'll have to use it though. So now I'm just going to write the equation in standard form. And I can always start it off just like that. So what number is going to go next to the x? 0 and 0 for both, or if you just wanted to leave that as x squared and y squared, that's perfectly fine. I always set it up standard form and just plug things in where they need to go. So I like this way, but if you want to do that, that's fine. So 6 is paired up with which variable? X. So what number am I going to put here? 36. Good. Squared. What number am I going to put here? 9. Beautiful. There it is. That's it. Okay. What'd you say? Yay! Hey, take those victories, run with it. Okay, so I don't care if you choose to draw them out. I actually, for this, I think I'm a very visual person, but I'm also a very lazy person. So yeah, I tend to not draw these because that takes more time. That's just me. I don't care what you do though. So the first thing that we need to do is we always need to find the center. Where is my center? 0, 0. Is everybody okay with where that came from? Okay. Smack dab in the middle of that. Smack dab in the middle of that. Then I need to think A, B, and C. So co-vertices is which letter? That's B. To go from the center to one of those points is how far? 20. And which variable did you do that to? To the x. Foci is what letter? C. And to go from the center to a foci, how far do you have to go? 8. And that was done to which variable? The y. Which variable will A be done to? The y also. Now, if you think about this, your general formula here is A squared minus B squared equals C squared. I do not know what A is. What is B squared? B squared is 400. C squared is 64. So A squared is going to be 464. Blech. It's a big number. I do believe 4 goes into that, though. How many times does 4 go into that? 4 goes into 4 how many times? Once. 4 goes into 6? once with how many left over? And 4 goes into 24. 6 times. And I think 4 goes into that also. So 4 goes into 11 2 times with how many left over? Because 2 times 4 is 8. So what am I left with? 3. 4 goes into 36. 9. So A is 4 square roots of 29. But you want to know something? You really didn't need to do all that. I'm a prankster. I know. That's me. Because when I write my equation is always, yep. My standard form is always like this, right? I know B was 20, and B pairs up with X, so what number goes here? 400. I know my center was 0, 0. What was A squared? 464. Yes, ma'am. Because A and C always go to the same variable. Always, always, always. Good question. Because if I look at this, what number changed? The X is what changes. Okay? All right. So, that's when you're given paired data. Okay? This stuff is not paired. I don't have 2 vertices. I don't have 2 foci. I gave you one of each, but I did give you the center. Okay? So my center is 0, 0. I need A, B, and C. C is kind of like a bonus. If I don't have C, I don't really need to find it. To get to a vertex, is that A, B, or C? A. To get to a foci, that is C. So, from the center to the vertex, what changed? The X changed, right? And how far did it change by? 13. From the center to the foci, what changed? X again, which is good because they're supposed to match. How much did it change? 12. Now, the C is a bonus. It's not really in the equation, but we are going to need it to find B. What is my formula that ties all 3 of those together? Uh-oh. Can you do these? What is 13 squared? 169. What is 12 squared? So 169 minus what gives you 144? Just look at it this way. 25. And yes, that's something I can take the square root of if I wanted to, but I'm just writing the equation, so I can leave that there. And so I'm going to say x minus the x coordinate, y minus the y coordinate equals 1. Make sure those are 2 separate. What number goes under x? 169. What number goes under y? Done. Okay? Now, foci. What letter is that? A, B, or C? C. Major axis. What level is that? What letter? A. So if my major axis is 10, what is A? 5. Good. Use that and write the equation of your ellipse. The major axis, bless you, for the major axis, that is the bigger of the total lengths here. It's to go from here all the way to here. It's like saying the circumference, kind of, sort of. And we want what would be equivalent to the radius. So how do you go from, diameter to the radius? How do you go from diameter to radius? It's just half of it. So that's how we got this guy right here. Okay? Yes?
Wait. Yeah, how do you know that the source is... Like, I know
It's in the middle.
X is, but...
It's in the middle. Okay? These are good questions to ask. Bless you. Check your final equations off of each other. And if you think you've got 8, go ahead and do number 9.
My sister's dog. It's fun.
Okay, do you think you got it? Let's take a look at the answer then. Oh, I did it wrong. Okay, and the reason why? What variable changed here? Y. That better? I get my X's and my Y's mixed up more than you guys do. Not a good sign, but it's okay. Yes, I do. Yes. Okay, why don't you guys try number 9? Be careful on number 9. The center is not 0, 0. So you'll have to think when you're talking about how far do I move from the center to the vertex, from the center to the foci. Okay, go for it. Did you do that one already? Okay, you guys ready for the answer? Yes! Doing okay? You got that? Take a look. Remember, an ellipse is always equal to 1. The only guy that's not going to be equal to 1 is going to be your circle. Okay? All right, so the last piece, and probably the hardest one, is just completing the square. This to me is the hardest piece, and it is just completing the square. And we're not going to sketch the graph. If you insist. I do. Ready? The steps are very, very, very similar to what you would do for a circle. So the first thing you're going to do is get your x's together. Get your y's together. And your number on the other side, or it keeps it there for this one. Now the place where this changes is the fact that we now have multipliers out in front. Okay? And if I were to just divide everything through by the number that has the biggest number, it would be ugly fractions. So the way that we fix this is we say, okay, here are my x's, here are my y's. I am going to take the 16 out of the x's. So 16 times what gives me 32? 2. And that's where I'm going to leave my space. I'm going to pull the 4 out of the y's. 4 times what gives me negative 8? Negative 2. And this is just where you've got to be a little bit careful because we need to remember these numbers are out in front. So, square root of x squared is x. Half of 2x, 1. 1 squared is 1. I did not just put 1 into my equation. What did I put in? 16, because I put in 1 times 16, which is 16. Square root, half of this. What's half of that? -1 squared. Sorry, did the next step already. But I did 1 times 4, which is 4. So 16 and 4 give me 20. 20 and 44 give me 64. And we have one more step to go. An ellipse has to be equal to what? 1. So what do you think I'm going to do? How many times does 16 go into 64? Nope, because 7 times 10 is 70. That's already bigger. 4 times. And use that kind of as a hint. That's usually what's going to happen. Okay, so I have x plus 1 squared over 4. Y minus 1 squared over 16 equals 1. Okay, now we are almost out of time here. So I'm going to give you guys your homework. I don't know, is your homework written on your sheet? Please write down your homework. We will do more of this practice next class. Next class, we're going to practice circles and ellipses. And you will take a quiz over circles and ellipses. Next class. But all we're going to do next class is review circles and ellipses. And then at the end, take a quiz over circles and ellipses. Okay, so we're going to do a lot more practice with this. And everything has now been recorded. And if you need to watch it through again, it will be online. I can find my cursor.